Welcome to this Wood Solutions presentation on timber's fire resistance and its fire resistance ratings. All materials have to comply with the regulator requirement for fire resistance when they are used in buildings. As a result, timber's fire resistance and its ratings strongly influence how it is used in buildings and other applications. There are three major areas of fire resistance regulated in Australia's building code. These are the timber's charring rate during a building fire, its bushfire resistance rating, and various other fire hazard properties required of its use in interior surfaces by the National Construction Code. Timber's charring rate influences how long a timber element will continue to support a design load during a building fire. The char layer that develops on the outside of the timber element in a fire slows the rate that timber burns. This is useful in the design of timber elements that have to have a required level of fire resistance. The charring rate can be calculated, and Australian Standard 1720.4 provides a formula to do this. The formula is the charring rate, or C, in millimetres per minute, is equal to 0.4 plus 280 divided by D, that's the timber's density, squared. So the higher the timber's density, the lower the char rate. The depth of charring on an element after a particular time can also be calculated. So the calculated depth of charring in millimetres equals the charring rate multiplied by the time in minutes plus 7.5 millimetres. So let's look at an example of this in practice. Assume that a glue laminated pine beam that is 400 millimetres deep and 100 millimetres wide is exposed to fire. In this case, the char rate will be equal to 0.4 plus 280 divided by 500, and then that result squared in millimetres per minute. In this case, the density of pine is assumed to be about 500 kilograms per cubic metre. When this is calculated, we can see that the char rate is 0.7 millimetres per minute. So if we expose the glulam beam to fire for 30 minutes, the depth of char on the beam can be calculated. It's equal to 0.7 multiplied by the time, 30 minutes, plus 7.5 millimetres. This works out at 28.5 millimetres of char depth on each exposed face of the beam, the bottom and on both sides. So after 30 minutes in a fire, the effective thickness left of the beam will be the original 100 millimetres minus 28.5 millimetres twice, that's once for each side. This gives us 43 millimetres of solid timber remaining on the beam after 30 minutes in a full building fire. Design with timber in bushfire prone areas is governed by Australian Standard AS 3959. Under AS 3959, timber is classified by fire resistance, and its use in particular applications is determined by that fire resistance. This resistance is classified by timber species, and that is based on its density. There are four basic groupings. The first is bushfire resistant timber, then species with a density greater than 750 kilograms per cubic metre at 12% moisture content, then species with density greater than 650 kilograms per cubic metre, and lastly other species. Bushfire resisting timbers may be bushfiring due to a number of reasons. The first is the natural properties of the material, then the impregnation of the material with fire retardant chemicals or the application of some fire retardant coating. Natural bushfire resisting timber species are listed in Appendix H of the standard. They include blackbutt, quila or murbough, red ironbark, river red gum, spotted ash, spotted gum and turpentine. These species had low heat release when tested for burning. The next classification is timber with a density greater than 750 kilograms per cubic metre. These timbers are listed in Table E1 of Appendix E of the standard and include all the bushfire resisting timbers mentioned above, plus species like jarrah, messmate and Tasmanian bluegum. The next classification is timber with a density greater than 650 kilograms per cubic metre. These are listed in Table E2 of Appendix E of the Standard and include all of the bushfire resisting timbers and other species listed in Appendix E1, plus additional lower density species such as alpine ash, pine, mountain ash and cypress. The last grouping is timbers that are not listed in Appendix E or H of the Standard. These are low density species that include radiata pine, western red cedar and similar soft species. The National Construction Code establishes requirements for the fire hazard properties of all materials used as flooring and as wall and ceiling lining in many types of buildings. These limit the ways materials can contribute to the hazard that building occupants face during a fire. The regulations target the material's behaviour as it burns and as it generates smoke. These are some of the fire properties required of timber and all other materials used in these applications. Information for many of these properties is available for most species on the Wood Solutions internet site. In summary, all building materials have to comply with regulated requirements for fire resistance. Timber's fire resistance strongly influences how it is used in buildings and other applications. The major areas of regulated fire resistance are the timber's charring rate during a building fire, its bushfire resistance rating, and various other fire hazard properties required by the National Construction Code. Information on each of these is available for most species from guides on the Wood Solutions internet site.